here we go. We are live right now. Now, this session today, it's just a kind of, let's say, completing what we have, what we already discussed about it when it's related to the model selection. Now, today we have a special, let's say, special celebration after this session, which is the first anniversary of integrated ML AI mentoring session. So I will try to make it light. I will start when we are talking about classification, I think it's deserved to mention what is the difference between classification task and regression task. I will start from here. Classification, let's name it, it's a kind of problem of identifying which of set categories or subcategories, subpopulation, it's there, and we are trying to make observation for it. Now, there is many methods to perform classification, but at the end, from this slide, I only want you to focus on the graph, on the chart that we have, which is when we have a population, we have some classes, some, let's say, ideas, some, let's say, subclasses, we have it inside this overall population. And the classification task, it's just only trying to separate or identify these classes. Now, this is as a general understanding, but when we are talking about you are building a model to predict which class is your sample is belong to, that means here we have to understand how much it's powerful to use classification in many tasks whenever related to any domain or business. We have multiple algorithms. We know that there is, for example, logistic regression. It can be used for linear classification. We have support vector machines. We have boosting method, decision trees, and random forest, neural networks. All of this can perform classification. But which model we are going to use? Before going to that part, which is by code, this presentation, it's already I already presented with Hugo last week. So I'm just running through it because I want to reach to the code part. The YouTube record, it's there available. So anybody want to back again to what we mentioned there from theoretical point of view, he can back to that records. I just want to mention them when we are talking, there is, let's say, always a kind of conflict might appear between the random forest concept and the boosting methods. Now, the random forest, it's at the end, we are trying to build multiple decision trees, the decision trees. Previously, there was another concept called binary trees, but decision trees, it's not binary anymore, let's name it. Okay, multiple decision trees that predict the classes for our dataset, and then from these decision trees, we are trying to find the class that we are looking for. To predict the class, we are trying to perform a majority voting, let's name it, over this n decision trees. Now, this is how that random forest is working. At the end, it's predicting on parallel, and then it's only majority voting. Now, this is mainly have a major difference. This name, we call it bagging ensemble method. It's different from boosting ensemble method, which is at the end, after this parallel step, we are not going to use the majority voting. We are going to build another sequential step to have a weighted prediction for each tree, and all of this, it's affecting the final decision. So this is the major difference between the boosting method, which is weighted based, and let's say the bagging, or the random forest method, which is more, it's parallel, it's more probability based, or let's say major voting is playing major role here. Now, both of them, it can be used for both regression and classification. Here we are focusing on the classification. Now, to perform model selection for classification task, we have first, we need to upload our data set. So according to that, we have to consider something. Here we are discussing about supervised binary classification tasks. That mean we have only 2 classes. Yes, Tom, please.
Just real quick, back on the bagging.
Yep.
You probably said this, but how? So basically, it's okay. It's a voting to see which model
Yes.
fit good for that small sample set of the data set, correct?
Yeah.
Okay, I was just making sure. Whereas in boosting, like Random Forest and Ada Boost and all those, it's really just an averaging sort of, excuse me, not a, yeah, is
No,
it
Tom, I
like an
think I
average?
think I think the measure, it's not average. In the boosting method, Ada Boost or XGBoost, we have the decision that comes from each model, from each tree, let's name it. It's together goes in sequence with weighted. That mean at the
Yes,
end,
okay.
okay, it's not averaging. Averaging, it's used in the decision trees for the regression.
So it's weak trees in a boosting method, weak decision makers, and they get weighted.
Yes, exactly.
Okay,
Exactly.
thank you. That, because I've worked hard on understanding decision trees, but I couldn't remember on
Since
the,
you mention it, I think it's nice. First, the decision tree, how we are from algorithm point of view, how we are able to build it. It's a very small trick we can do it, which is sorting the columns. I will back to this one. For example, if we have this CSV, to build this decision tree after the encoding, for sure, we are able to create a sorting method. This sorting for each column, for each field, for each feature that we have. The sorting, it will, then we can start from the field or the feature that have more sparsity. That means it has a lot of values, make the sort, and then to the next one, until we finished. Now, once we make this sorting, parsing this fields, if we consider the major sparsity, let's say it's the most important feature, up to the least one. So this is one of the trees that we created. Go and make it reversed. This is another tree. So decision tree, building the decision tree from algorithm point of view, it's not that much hard task, but each time we are supposing or assuming something. That's why decision trees sometimes might not be good classifier or predictor for us. That's why random forest and the boost method, it's doing better, because always we are assuming in decision trees. For sure, this assumptions, it's not random assumptions. There is some way, we can find algorithmic way also to make these assumptions.
thank you for that. That really helped.
Okay, so I select, I'm not going here. Our target is to find the final results according to multiple classifiers and find which classifier is doing better, and parse, let's say, only parse the code to perform that using sklearn. So the code here, for sure, I will provide also the notebook for this one. It's very simple, but also it explains a lot of things. There is 2 major assumptions. The first one, we are talking about supervised binary classification. That means we have only 2 classes in our case, and we are going to use the breast cancer dataset from sklearn. Now, breast cancer dataset, this is how we can call it, how we can import it, and then load it as X and Y according to which what is our label. Now, the other part, it's how to split it. Here I make the splitting as 25%, but always we mentioned that during previous sessions, that how to split your dataset, and we said that it's almost related into training and test set. It's almost related to the size of your dataset. So if you have huge data points, we have, for example, over than 1 million data points for your task. And here we are not talking about time series. We are talking about other tasks, not time series analysis. Okay, at that point, I think it will be suitable to reduce the percentage of the test sets. No need to make it as 25%. In case it's less than that, I think 25% would be okay. In bagging and binary classification, 50 says 1, 50 says 0. How this case handled, or if such a thing never happened? Here you have it's typical classification task. For example, in this case, you are really not sure to which class this sample or this data set that sample is belong to. So here it's depending on you and your threshold about the average voting or the voting method that you are following. Maybe sometimes you are going to shift it according, make some kind of PS according to your case. So this is not only for the trees. Anytime when you have this 50% probability, it depends on your threshold and your data set. And here for classification, there is major assumption that we have to consider. It's coming soon. This is for Hitesh question. Okay. So in our case, yes. Okay. I didn't get you if you said something.
Yeah. No, thank you. That.
Okay. So in this case, we are splitting the data set as 25% as a test set, and the train set, it will be 75%. Now, what is the random stat? The random stat, it's a number that we are going to use it for being sure that each time we are running our test, our experiment, we have the same random splitting, it's happening. So according to that, we will be sure that it's not, there is no major change. So when we are testing our results, we are sure that that means we have the same splitting method that's appeared there. So this is the random stat. Understanding the random stat 100%, I'm not sure with it. Sometimes you can ignore it, but at the end you will get the new or different data set each time, even if it's following the same percentage. So this is the main difference of using the random stat. Now, beside that, if we, okay, what's the model that we are going to test or to try to make the classification for it? We will try logistic regression, we'll try random forest, key nearest neighborhood, which is, it's nice method to have it on the as classifier, because, and according to your key number that you are going to follow, it's look, by the way, key and n, it's look like clustering method, but it's supervised learning. It's not unsupervised learning method. So somehow, because you are already decide what is the key and also what is the centroid for each cluster or for each class. Support vector machine, also we are going to try it. Gaussian naive Bayes and the XGBoost. Here we are not going to run a neural network in this example, but at the end you can check how the main target again for our session today, it's to perform as simple as possible a model selection for our task. This is the most important. So we are not going to discuss deeply about each model structure, and most important, I'm not going to mention anything related to the hyperparameter for each model. We will use the default hyperparameters. It will be a task for you as learners to check about it, and maybe we can add something from your side in the next session if you want to go deeper for each model. Okay, so mainly it's the model selection, how we can perform a simple model selection. So this is the models. What is our target? Our labels, it's two classes only. Either it's bad, let's say, sample that we have, or it's a good sample. In medical terms, I will find it later because I don't know what is, I didn't save it by heart. So at the end, we have two labels. Okay. And we have here, it's very important notice. Since we are talking about classification, it has to be balanced data set. imbalanced data set will never work. Why? It might be different from regression task for one reason. We need our model to be trained, and our weights, whatever the weights that we have, our random forest and all the trees for that random forest, it has to be trained equally for both classes. That means we are trying to raise the sensitivity to have equal sensitivity toward both classes. In case it's not balanced data set, our model will work better for the majority class, not for the minor class. So in classification, it's very important to balance your data set. We already discussed about how to balance our data set. You can find it also on the record on the YouTube. The session was by our friend Sadiq Mohammadi. He performed this session and he gave us a clear example about how to balance the data set. Now, we have to import the libraries that we have. All of them, it's coming from sklearn. Only the XGBoost, which is also to run the XGBoost, you have to import sklearn also. NumPy and pandas, it will be useful. Beside that, we will import this classification report because it will help us to generate the report, the final report that give us clear comparison between the models that we are going to use. So in general, all of these libraries, all of these models, it's already imported, and we will use the name as it is at the end. Now, here we are running the experiment, our experiment. So as we said, in the initial running, we are only trying to make a model selection. So we are not going to try anything related to the hyperparameter of each model. So mainly, we have the following parameters. Practice and play a lot on Python. Yes, Tom, sure. Xtrain, it's the training data set. Ytrain is the labels for the training data set. Xtest, it's the test data set. Ytest, the test that labels for the tests. And the results will be also data frame coming from pandas. It's contain all the results that we find for different models. That means our final results, it will be the target from it. It's having a clear understanding how different models perform toward this task, which is classifying a breast cancer data set into good sample and bad sample. I will check again. In the next slide, we will know exactly how medically it's named. So DFS, it's our initial data frame models. Here we are creating this. We already have the name and we initiate the model. We call this constructor to initiate the model, and already we have it on this dictionary. So mainly this is our models that we are going to use: logistic regression, random forest, key nearest neighborhood classifier, support vector machine, Gaussian, and XGBoost classifier, because XGBoost also it has regressor. So we have to be sure about it. And the same for the random forest. So when we move to the next slide, we still on the same function, which is run the experiment. We have, okay, right now I find it. It's malignant and benign. Malignant is the bad sample. That means this sample is showing a breast cancer. Benign, it's the good one, or I don't know how to say it. Okay, so again, we are having the results matrix, the names, and then what is the scoring that we are going to follow? We have the accuracy, precision, recall, F1, and for sure ROC, OUC, area under the curve. Now we have the models. In the model dictionary, we have the names, so we are going to run. Here I'm doing something just to tell you that there is no limit for your decision. At the end, you have to practice and to try it. I'm again creating a k-fold, which is already, we discussed about what is the k-fold cross-validation for the training set. We already split the data into training and test set. Why I'm using the k-fold once again here? It's just to tell you that, okay, try, go ahead. mainly you can find there is no logic from that. But at the end, in the k-fold, still you are running that, let's say, fitting or training your model toward all the folds that you create and find at the end the average performance. So using the k-fold, it will give you better understanding about the performance of your model than just only train it on the train set. But here there is major thing, the test set, we didn't include it in the k-fold. So here it's a different scenario, but honestly, I feel this is not the best scenario that you are going to try. I just make it like this for you to tell you that there is no limit to what you are able to do. At the end, you have to try and find what's the best method to follow in training your model. So simply, as we already did, we already show that for each model we are fitting the model again against the X train and Y train, and then we are also create the prediction for the test set and start printing. We will start from printing the name of the model, and then we will print the classification report. If you remember, I told you that we import this just to help us to print our results. So the classification report, it will be showing us our matrices, our evaluation matrices against that test data set. Okay. Then we have all the results. We can append it together in the results fields and return it to the end. So nothing major. There is no major problematic things happening here. The most important that we already construct, build all the models, call all the models in one dictionary, and we run it together to give us the final results. So this method, it's very simple, easily you can run. By the way, only the difference that when you need to tune your hyperparameter, but at the end, this function as it is, you can get it and run it against any other task to find which model is suitable for you. So as it is, you can use it. For sure, you can add to it. Now, the final result, it will look like this. We can find that logistic regression. This is our matrix for the logistic regression. This is the accuracy for it. For random forest is the same, and you can consider also the other models. It will appear like this. In our case, we can find that the random forest somehow it's showing better performance, but still you can check maybe the hyperparameter for each model at the end. Now, if according to my results, when you check again the XG boost, it was doing better, to be honest. So just I will back again to tell you that this function, which is in these 3 slides, you can use it as it is, only hyper tune the parameters that you want for each model. And at the end, it will help you as a model selector for any classification task you are going to follow, unless you want to test the deep learning scenarios in case you are dealing with image, for example, or other kind of data sets. But whenever your data set, it's CSV file, and even if it's a huge, you can check this one to give you the intuition about which model it will help you better. So mainly this is our presentation for today. Tried to make it light. Hopefully it was light really. And now let's open to the question if you have any question. Okay, this is surprising. Okay, I have to add this. Hugo, also you have to follow with me if you are here. I will provide the notebook also for this one with the full example that you can find the results, because in the notebook also I add something related to visualizing this result and visualizing also the time needed to fit. So in the notebook, it's not only how to select the model according to the evaluation matrices, also what is the time to compare the time of training for each model and time of predicting also. So the notebook, it has also another 2 functions just to make better comparison between the model. But Hugo, if you are going to follow up with me on Tuesday, not before Tuesday. Yes, Tom, please.
Guys, would you be okay? You remember those images I came up with the pseudo math and all that? Could I just share that as a way of augmenting the confusion matrix talk?
Okay, sure.
So let me share we'll make this brief, and if anyone
Yes, sir.
likes, it would be fun. I can share the LinkedIn posts that I did on these. I did them just because. Oh, go ahead.
I was looking for it, by the way. I want to show it exactly, but because I have a problem, I'm right now, maybe within next month, I will buy another laptop. I have problem with my machine. So that's why I was looking for it, but also it's not helping me, the machine itself. A lot of restarting, and that's why I only finish my notebook and the presentation and go on. Yes,
Yeah,
that's perfect.
I had to do these for myself, guys, because guys and I just want to make the book really super clear. And these were my efforts to, okay, what is confusing about confusion matrices? And so I just started
Yes.
picking it apart. And this one was the most fun. When you can boil it down to what I like to call pseudo
No,
math.
just sorry for that. I think
Yeah.
the image is shown in another screen. We cannot see it.
Oh, you know what? Thank you. I got the wrong screen. Yeah, that was embarrassing. I know why I did that now. Here we go. I've got them all together. And I'll make this one bigger here in a minute. But focus on this one right now.
Yep.
These are the three. I think these are the three more important to look at than F1 score. And I'm going to explain why. Now, first of all, you need to think of all of these as rates. So if you do want to look at an average, you need to be looking at the harmonic mean, which is the mean you use when you're working with rates. And there was a guy that wrote a great comment about how to generalize these harmonic means even more. Like this number, if you were doing a harmonic mean on several values, this would go up according to the number of values. And then if your sample sizes were equal, you would have them proportionally change here. But I'll add that in another picture for y'all soon and do another post. But accuracy, well, we look at that, this can get confusing. Okay, true positives, true negatives over the true positives, true negatives, and the false positive, false negatives. Well, hey, that's simple. What we got right over all cases. That's probability. What was the proportion we got right? Okay, recall. Now, recall, in my opinion, is the thing we need to be looking at most of the time. It literally is the accuracy. So over here, think of this as the positives. This is the distribution of the case that shows that our null hypothesis can be rejected. And so we're doing a test, obviously, and like in a confusion matrix. Well, we can look at more than just the what positives we got right over all actual positives. You can also look at all negatives we got right over all actual negatives. So you can have a positive and a negative recall. You can have a positive and negative precision. Now, precision's helpful because it's telling you how tight your two cases are, how tight those distributions are. But it's not really giving you an accuracy. This is breaking down, recall is breaking down the accuracy into the two different cases. So when you see this TP, you can replace that with a TN also, and then a false positive. So you just invert these for false positive, recall, positive recall and negative recall, positive precision and negative precision. Now, let's look at this. Oh, I can't make that any bigger. Darn. Well, it probably can. Yeah. I'll just make this. Now, F1 score. There, a lot of times we get in the habit of just doing things because we see it done a lot. And I'm just going to tell you, I don't think mixing these is that helpful, personally. Use F1 score to help you, but don't think it's all that. I think the better measure to look at is a balance of accuracy and the positive recall and the negative recall. Now, when you get more than 2 values, though, it can be super helpful to remember, okay, here are my true positives, here are my true negatives, but these are my false positives and negatives. So you can see now it doesn't matter. I can go to bigger and bigger I can have more and more classes, bigger and bigger confusion matrices, and I can tease out what's going on when I see it all together like that. And to see hopefully you can extend the other cases. If this comes down to here, this green one would go up here. In other words, we're looking at the true cokes now. This spreads out to where, oh boy, you know what? I'll put a summary group of these together for you guys, but try to keep it private for Garth and I, because this is stuff that will go in our book. And yeah, I hope that those 3 images help a lot. But I think these 2 are the more important.
For the recall, Tom, I have, just because the positive recall and negative recall, I want to highlight something that we name it sensitivity, which is more related to the positive recall. The sensitivity or the positive recall in this case, sometimes you are according to the task. Now, again, how the business acumen that it's reflect to your work exactly. You are designing your model in a way, for example, to increase the positive recall, and you are accepting losing some accuracy according to the negative recall because of the case. I will give example here. If we are predicting, for example, COVID, which is, by the way, most of this confusion matrices is used for evaluating the COVID test, even the rapid test and all other things. Sometimes we are accepting having a wrong positive result from this rapid test because it's more safe to tell the patient or the person that please go ahead and make another test to be sure that you are positive or negative, because the most important is when you tell him that he is negative, he has to be negative 100%. So in this case, we are raising the sensitivity toward the positive to even include some negative results. So here, how the business itself, that or the task that you are going to perform, it's bending or changing your direction. Here, not how much you are accurate is more important, it's how much you are safe. So this is how accuracy alone and the F1 alone is not enough. Sometimes we are looking especially for the sensitivity or for the specificity or whatever it was. Now, this is what you're showing right now on the screen from Wikipedia. It's really great, and it's explaining exactly how to find all of these matrices.
Sorry, I went mute. And this is just from Wikipedia, like guys said, and I am not always the best example to y'all about perfect terminology. I kind of like here's sensitivity, recall, hit rate. We still have a multiplicity of terms for everything in our arts, but when I'm saying when I'm speaking positive and negative recall, I'm just doing it to make it simpler in the pseudo math thinking.
Exactly.
In other words, here, when I say negative recall, we could say, well, all negatives we got right over all actual negatives. So basically for each of these, just flip the P's and the N's. What I'm really trying to emphasize is sometimes in your case, you care more about accuracy on negative recall than positive recall. And sometimes the opposite. It's going to change according to your particular modeling needs.
I would like maybe since I didn't post anything on LinkedIn for a while, I will post about this, the recall, precision and sensitivity and specificity, and how they are mixed together. Okay,
That would be great.
this is a great, but I will post it as examples. Okay, so how we can change our model performance according to our task. This is the most important part, because again, I don't believe that there is a model. All the model are wrong. We know that. So we need to build the model that meeting our business needs, not meeting the fact. The fact it's not there.
Yes, yes. And guys, I need you to give a message to the director of data science at Bayer for me. Tell him that his data scientists and himself are not contributing to LinkedIn enough lately. They have a lot of wisdom to share and they need to share it more often. You tell him that for me.
I will.
Make sure he knows
but,
I'm teasing him, but being a little serious too.
Okay.
By the way, everyone, we're talking
why
about...
you not telling him? Why you not telling him? Because
Yeah.
I will tell you something. I'm not going to New
Don't
York.
do it, actually.
Okay, but he is going there. So why you telling him? Okay.
Yeah, I'm gonna tell you're not making enough of your team travel with you. No, guys, just so you know, Giuseppe Bonaccorso, the guy that wrote Mastering Machine Learning Algorithms in Python, is Guy's boss. And
Yep.
we used to do shows together a lot, but then Giuseppe just decided this is not making my life fun anymore. And he really was being taxed. But we miss hearing from him because he's such a genius. But guys, if you what I think is more important is look at this this page and take it a little step, a little bite at a time, and think of it this way. All of you, I kind of meant this post, and I should have emphasized this more when I posted it. Take apart just keep thinking more deeply about what the confusion matrix is telling us and all the different metrics we could derive from it. What I'm trying to emphasize is don't get stuck on one metric like F1 score. Instead, think of all the different ways you can understand the confusion matrix better for your own needs. You can create your own metric that makes more sense for what you're looking at. That's the key here, guys.
Yes, I agree 100%. Yes, sure. And by the way, this is also just for you, all of you. All of these matrices, it's coming from true positive, true negative, false positive, and false negative. So when we understand this fact, at the end, it's very simple and easy to find the suitable metrics for us. So this is also, just to simplify it to the basic, it's only statistical work about the true positive and true negative, and what's the false positive and false negative. So I hope this was very helpful. I'm looking for, honestly, my machine destroyed my life for 3 days.
Oh no!
but I was looking for this especially because I think it's always good to back again to our confusion metrics and explain the concepts of it, because it will help a lot and it will give better understanding for everyone. Thank you, Tom, for that.
Oh yeah, thanks for letting me chime in. I just learned something. I can't turn off reactions on Linux when I'm in sharing mode. But I'm just really doing what Tina used to do. Just when I think more deeply about something and I gain some more insights, I post about it. I'm really hoping the family will keep doing the same also, because I think, just share your growth with others, and it's good.
Okay, I think we are in good place. Unless there is any other question from anyone, we are in good place to stop. So we'll go to the celebration after that.
Yeah, let's give everyone time for bio breaks and such. Were there any questions for Geif before we go? One last encouragement, guys. If you were overwhelmed or just felt like you didn't understand much of this, do not feel bad. A lot of times it takes multiple exposures to something to begin to understand it more deeply. So please don't be harsh with yourself if you're not understanding all of it. Just keep coming back to it after you've taken a break. Start practicing with it. Start some very simple toy data set practice with it. You'll start to understand it. And then ask a lot of questions on Slack or in the class. And Hugo and I will keep pushing that very beginner stage stuff in the Saturday Tech Time chats too. So that's all I wanted to say in case anyone was feeling overwhelmed or lost. Don't feel bad about that. That's part of the journey. All right.
Okay,
Thanks, Aziz.
I will stop the live streaming.